acid. Our acid is hydrochloric acid. So the question is, a 25 centimeter cube of hydrochloric acid solution is titrated with a 0.1 molar sodium hydroxide solution. If it takes 30 centimeter cube of sodium hydroxide to neutralize the acid, determine the concentration of the acid. Determine the concentration of the acid. Therefore, this is going to be very simple, and I want you to follow the stepwise solution. Okay?
Yes.
The first step we have to do. The first step is to write the equation between the sodium hydroxide and the hydrochloric acid. The hydrochloric acid and the sodium hydroxide, when you react in the base with the acid, you form salt and what? Salt and water.
And water, yeah.
Okay? You form salt and water. Therefore, our salt will be sodium chloride plus water, H2O. Okay? So the H2O, which is our water. Now, when we look at the equation, we find that the equation is already balanced. Okay?
Yes.
This is the first step of the solution. Okay? Yes. Now, this one here, you look at the equation whether it is balanced, and you find that the mole ratio is always 1:1. It's 1:1. The mole ratio is 1:1 because the mole of HCl is 1, the mole of sodium hydroxide is also 1, the mole of sodium chloride is also 1, the mole of water is also 1.
And the hydrogen is 2.
It's not, if you don't look at the hydrogen, the number of atoms is 2 in 1 mole of water. Number of oxygen atom is 1 in 1 mole of water. You look at the mole of water is 1, the mole of sodium hydroxide is 1.
Okay.
Okay? Yes. Now, having known this is the mole ratio.
Which means we know this one, hydrogen.
Yes. The hydrogen is 2 here
In this case.
In this compound. This is a compound. Water is a compound. It's a molecule. It's a compound. Okay. So in this molecule here, we have 2 atoms of oxygen, but the number of mole is 1. If there was a 2 here, then number of mole is 2.
Okay.
Okay? If there was a 2 here, number of mole will become 2. But now there is no 2 in front of the formula. Therefore, we conclude the number of mole is 1. Put together. Yes. Now, we come back to our equation. What is given? We are given the standard solution. The standard solution, the solution with known concentration is sodium hydroxide, right?
Yeah.
This is our standard solution, sodium hydroxide.
Yeah.
And this sodium hydroxide will have another volume, there's a volume, right?
Yes.
So therefore, we can say from, this is the second step, from the standard solution, which is sodium hydroxide. It is given that we have 30.0 centimeter cube of 0.1 capital M sodium hydroxide. We are going to find a number of moles contained in this. Okay?
Yes.
We are going to find a number of moles contained in 30. Since we already know number of moles here, this molarity means that this molarity here, it means that this number of moles is contained in 1 liter.
1 liter, yeah.
1 liter is equivalent to 1,000
1,000. Yeah.
right?
Yeah.
Yes. And therefore, you can say since we have 1,000 meter cube, we contain 0.1 mole of sodium hydroxide based on what is given here. How about the 30?
Solution
30 centimeter cube
is called equation.
will be equals to a y.
Y or X.
We give a known y or x, right?
Yeah.
Now, we turn this side. So, our y will be equivalent to what?
You make cross multiply.
We make cross multiply. This will be 30.0 times 0.1 all over 1,000. What do we get? If we can calculate, what do we get?
minus 0.1 divided by
1000.
0.3.
0.3, very good. 0.03
like that.
0.03 like this, huh?
Yeah.
Okay, good.
There's another zero point.
There is not 0 here?
There.
Okay, 0.003
Yeah.
moles of sodium
Sodium
hydroxide.
oxide.
Okay?
Yeah.
Now, we are going to use number of moles of sodium hydroxide to determine number of moles of the acid that reacted. This is the important of the equation. We use the mole ratio in order to determine number of moles of the acid that reacted. Okay? The mole ratio between HCl and sodium hydroxide here is 1:1, right?
Yes.
So therefore, this one will also be the same, 0.003. So the mole ratio is 1:1, then we can add also 0.03. Okay? So therefore, we conclude that there are 0.003 moles of HCl. Okay? Reacted with the 0.003 moles of sodium hydroxide, right? Of sodium hydroxide. After having known now number of moles of the acid that reacted, and we are given the volume here, 25. So we believe that this 25 here is the one that is contained in this.
That value.
This 25 here is the one that is contained in this volume. This 25 moles, this number of moles from the mole ratio, okay? So therefore, another step is determining now the concentration. That is the molarity now of the concentration, okay? Of HCl. How do you determine the concentration of HCl? From here, we have 0.03 moles of HCl is contained in this volume, which is 25.0 centimeter cube solution. Right?
Yes.
Now, how about the X volume, how about the X moles? That will be contained in 1000. This is now the molarity. Okay?
Yes.
The molarity is the number of moles contained in 1000 centimeter cube or in 1 liter. Okay?
Yes.
So therefore, we cross multiply and solve for X. Our X will be equal to 0.003 moles times 1000 all over 25. What would be our answer? What will be our answer?
0.122.
0.122?
Yeah.
Okay, 0.122. 0.12?
2 like that. Don't write another 2.
Okay, 0.12, right?
Yeah.
Capital M, HCl.
Epsilon.
This is our concentration of the hydrochloric acid.
Acid.
Look together.
Yeah.
The concentration of the hydrochloric acid.